Hey everyone, it's AJ from Pixelize. Today we're gonna go through a little crash course on SQL. So if you're interested in how to create databases, tables that you have, how to create a relationship, insert types, delete them, update them, again, how to utilize this, whether you're using WordPress or anything else, it will be quite good to learn about databases here and how SQL works, because then you will understand better how to implement this in your project. So first things first, what I want to do though is cover the basic topic, which obviously is different data types. I'm not going to go in depth into them. I'm just going to quickly show you them and just read them out, which is int, tiny int, small int, medium int, big int, decimal, float, double or row. Anything to do with numeric data types, this is what you would use. All these data types are in SQL documents if you want to do. And if you're interested in what I'm using is my SQL Workbench. So you could download this for free. You could use php-admin if you want to on your local machine. It doesn't matter. You could even use the command lines if you have that installed. This is a specific one for creating SQL. The second data types are strings, which you got char, varchar, text, tiny text, medium text, long text, blob, tiny blob, medium blob, and long blob. More than likely you won't use a blob, maybe for like images and files. But again, look into the documents. We have number 3, which is date and time types. You got date, time, timestamp, which is most common used, year and time. The other boolean type, the other data type is boolean, which is as a boolean or bool, which is L is for boolean. And lastly, we have something what it's called other data types, which is enum, a string object with a predefined set of values. So let's say, for example, you have a product with different sizes of shirts, so small, medium, large. Extra large you won't be able to insert it in the table. You have to select the ones that is, otherwise it throws you an error. Pretty much to say you got JSON and universal unique identifier, which is not that commonly used. Okay, so hopefully you sort of got a rough idea on this. What I want to start with is something very simple, is how to create a database, because at the moment we haven't created anything. All these are your databases, and in the databases you can see you have columns, so like bookshop, books, and listings, and then I could quickly show you what they look like. So technically we could use this on how to select stuff. Select is very simple, which is select from and so on, but instead of doing this, I want to basically show you how to create everything from scratch. Okay, so let me just clear this out. To create your database, here's a command. You type create, always do uppercases, create database, and let's name a PXL, or maybe let's name a online shop, and then exclamation semicolon, execute. It's done. Now you may not see it because you need to refresh it, and there's our online shop. To select this, you could either double click on this, or better, use a command which is use name of the online shop, and it selects. Now that we have a database selected, now we can create a tables in it. So let's create first table, which will be users. Create table users. You have to open parentheses, put a semicolon at the end, otherwise at the end you won't be able to execute. The first thing is the name of the column, which would be ID, then the data type, which will be an int, and there are many different constraints, like conditions. So I'm just going to cover some of them because honestly there's too much. I don't want this to be way too long. I want this to be basic for you, because you could go quite advanced into this. However, for the purpose of this learning, we don't need to, and mostly you won't use that. So primary key, which sets as a primary identifier of the table, and we could put auto increment, which means automatically will increment. If you want to create another column, you just put a comma. Let me just look at my table so I know. We're gonna put first name would be varchar. Let's say there's 200. Maximum you can have is 255. We're gonna set this 200. Not null, which means the column cannot be empty. It has to have a value. Last name, same thing. I don't think anyone got longer name than 100 characters. Then we're gonna have email, which is gonna be varchar. 255. Not null, because we don't want to empty. We want to make sure it has got value, and we want to set a unique. So it has to be a unique value. It cannot be the same. So if someone's going to create a user going to register, right? Let's say to your e-commerce website or your blogging site or whatever, they cannot have the same email in a database. It has to be unique. Now we're going to create add. We're going to use timestamp, not null, and then by default we want to have a current timestamp. So when someone creates this, it will insert a default value, because we cannot have an empty, so by itself creates the inserts the default value, whatever the date and time is at the time of creation. Also, we're going to have updated at timestamp, not null. The default will be current time, because when it's stamp, because when it creates, it will create the current time, which is the same as the created. But if you want to update it, let's say user, you're going to update your email or your first name or last name or a username, we could set a condition which is called on update, and then we need to put current timestamp, so automatically picks this up for you. Okay, it's just good to know that conditions are there. Now to execute this, you could either click here, click there, or shift control and enter, and boom, the table is created. Currently we cannot see, but we could refresh this. If you want to see how many tables you have in your database, you just put show tables, and currently we only have one table. If you want to know what kind of columns you have, you could click on online shop, or you have it on your left side here. But whatever you use in sort of interface or even command line, you have to put the command show tables. Sorry, not show table. Describe DESC, and then you put the table name, which would be users. You execute this command and it gives you all the columns, the conditions, and everything you have set up there. So it cannot be empty. It's a primary key, it's a unique key. We could set up a specific index because it's for querying, which I'll show you that later on. But that's typical. Hopefully you can see this, how easy is this. Now we need to insert some values into our table because we got none. So I got some names. Here's how you insert. I can't even spell it. Insert into. Then we need to put a table name, users, brackets. Now you might think that you want to list every column name, right? So let's do this for a second. Email is next. Created art and updated art. But the problem is you don't need every single column because we know that ID, it gets auto incremented. So when it's created, it assigns ID by itself. So we don't need this. Created at and updated at, we don't need either, because it will automatically create the value for us. So only we need is first name, last name, and an email. The next, you put values and you insert the values. So I go John Doe, and the email will be john.doe@example.com. Now you could put this on a new line if you want, doesn't matter, because the query get executed once you put a semicolon, and then you execute, and it has been inserted. So let me just open new query, and we're gonna put, I will explain what this means in a second, but we have one data inserted. Now you could insert multiple values at the same time, so I'm going to show you. Let's change a name to Jane Doe, and then all you do is put a comma, brackets, and put, let's say, Alice John, could have thrown me an error, Johnson, and that will be alice.johnson@example.com, and let's say we put one more, which would be, this is what happens when you want to do it quick, it messes up, Williams, bob.williams@example.com. Now we just execute this, it's created. If we go back to our other tab, we have 4 users, both of them were created at the same time because multiple values were created at the same time. Obviously this one wasn't, but now we're gonna just add one more user, which will be Charlie Brown. And let's see if we can insert the same email, because it should be unique. And it throws us an error because it says duplicate entry jane.doe@example.com for key user email. So we cannot insert because we put a condition of unique, which is a good condition to put just in case you want to have a unique emails so they're not duplicates. It's sort of like a safety mechanism, you can think of this. Now it's been inserted. If I go to my other tab, boom. So we go with the users in our table. Now this command is how you select everything from a table. That means all the columns and data. So select, asterisk is everything, from, and then table name. If you want to select something specific, like first name and last name, then just do that, and we only have first name and last name. Also, you could give them aliases as, I don't know, person first name as person last name. So sometimes you might want to rename those columns as aliases. Typically we do this when you format the date, because you have a function like date format, I think is something like that, date format, can't remember off the top of my head, or format date, something like this, and then you have to use an alias name for this. But obviously that's a little bit more advanced, that's why I'm not covering this. You could have like count as rows, maybe I clicked the wrong thing. So we have a 5, and we could rename this as columns, So we got 5 columns. So you can see there's different functions that we can use. But you know how to create a table, create database, create table, how to obviously create your columns in a table, how to insert the data into the table by using insert into, table name, the columns that you're going to use, and the values you have to insert. Then you could select everything from the table, so select asterisk for everything, or you just name the column names and separate them by a I forgot what it's called now. This, it's out of my head now. It's not semicolon because you end the statement by semicolon, but you just separate them by a separator. I literally can't remember now what it's called. My mind went blank. Anyway, if you want to update, let's say Bob, last name, right? So what you want to do is update. Then you need a table users set last name, which is column name, equals, you give a new value here, let's say builder, and then you need to use a clause where it's where, and you need to put the identifier. So you would always typically use ID, because I'm going to show you the problem when you use, let's say, first name in a second. Equals, and we can have a look. His ID is for in a web platform, let's say, for example, like WordPress. WordPress will have the user ID saved in a session or on your e-commerce, right? So that was for. Let's execute this. So username has been updated. So we have it, as we can see, it's Williams. But if you run this query, it's Bob the Builder now. And it's been updated as well, because these three have been created at the same time. But if you notice, it's been updated. So now it's 2:35:30. So if we put it back to Williams, we see the time and we see the name. Select. It's been updated again. That's why the clauses are important to know them. So if you want to have track of updates, so when they're first created and when they're updated, you could create another table of this, like a revision, but I think that's going to be blowing up your database and slowing down your website in the long term. So we know how to insert, we know how to update, we know how to create tables, we know how to create databases, how to name the columns and conditions. Next is how to delete a user. And first, what I'm going to do is create a user. So insert with the same name, user, insert into users. I don't like this one, it's covering. And we need an email, so we just need to make up email, and then values. So I'm going to use John Doe again. John Doe, and then email would be doe.john at example. Remember, we can insert the same names because it's not unique. Only the email has to be unique. And if we look here, we don't have a John, but we have a John.Doe, right? So it's absolutely fine. We'll be able to insert this. Now, why is this select all from users? So we have two Johns. Typically, again, you will use ID to remove the user. So we're going to select two deletions here, okay? Now, let me delete. So you put delete. And then what you have to do, let me just double check, make sure I don't put the wrong thing, from users where, and then you would use ID here because it's the most way, it's probably the more accurate way and safer way to do it. Let's say we're going to delete Bob. We're just picking on Bob today. So now if I run the query, you're going to see Bob will disappear. So ID4 doesn't exist, Bob is deleted. But now we have two Johns. And let's say one of them by mistake created two accounts. I need to delete one of them. This is the rule original, this is the duplicate. It says the example of an email is different. And we cannot update the email because it's unique, right? So if I put where name, first name, equals to John, I'm going to show you what we'll do. It won't throw you an error, but it's going to cause you a complication if you're building a website or platform, whatever. It's been deleted successfully. So if you're going to now select, just ask your question first yourself, which John is going to be deleted, the first one or the last one? So both Johns have been deleted because we use the first name. So if you had 10 Johns, all 10 Johns would have been deleted. That's why ID is a specific identifier. That's why it's a primary key, because you can identify a lot of things by ID. So we just need to now insert those John and Bob. So insert into, or maybe just leave it for now. We don't need it. Doesn't matter. So hopefully you understand the most basic stuff. Next one I want to show you is we're going to create another table called categories and then another table called products, and we're going to create a relationship between them. Okay, so create table categories ID int primary key, not null, auto increment, category name, description, long text. We're just gonna create this. We're gonna comment this in. So you could do highlight this, control and / and create the comments. The other thing you're gonna now create is another table. So we're gonna create this table as a first, actually we're gonna insert the values into the category because we need this. So insert into categories. So we need name. This description is optional, and I'm going to show you in a sec why. For now I'm going to put it on. We could put this on another line, which would be better to read. So we have a electronics. I think I spelled this correctly. I'm just going to copy and paste that the table I have prepared. I'm going to insert another at the same time to save us time. And I will explain you exactly what foreign key constraint is. You will see why it's useful. One more, and then we're going to leave one empty. That's inserted. So if you have an optional, obviously long text, and it can have an empty value, you can obviously do this, but you have to programmatically do this at the back end. Otherwise, you'll have an error coming up, because you cannot have this and then have this empty, right? Because I'm going to show you, it's going to throw you an error. It cannot insert because column count doesn't match value count at row 1, because you have one more column. So you have to remove this. Let's put this on one line, and let's name this and we have this inserted. So let's have a look at the categories, right? Select all from categories. Let me just refresh this side so we can see here. So we have category names, description. One of them haven't got, but we got ID. Now I want to show you how the relation with foreign key works. So how it works is very easy. We need to now create a product table. Okay, create table products. So we need an ID and primary key, auto increment. Then we have a product underscore name for show. Let's say 255, 155 doesn't matter, not know. Price would be int, not know. Quantity, oh, misput there. Quantity be int, not know. Now, instead of putting category name on products, we could reference the table that already exists with the category names, like you have, for example, in WordPress with taxonomies and tags, right? So we can create category underscore ID, which will take int, not know. So the question is, how do you reference this, right? Because you could do this without even referencing, but the problem I see here is that you don't put a condition and force the relationship. You have to manually manage that. So we put for a keyword called foreign key. We have to name which that's going to be assigned to, category, which is category underscore ID, and the table that we need to references would be categories ID. Okay, so if it's confusing, that's absolutely fine. We created this table before, that's why I left it here, which basically it's a table of categories like electronics, appliance, all this stuff. We have an ID for this, we have a product name and description as optional. Instead of naming the category in a product, we can use a ID to reference that, because when we select the table, it will be easier to find all the products under the category ID. You could join those tables together. It's more organized and more efficient that way, and a cleaner way to keep your data organized together, right? Now, with a primary key, you could have it here, or as an example, primary key can be here, and then you could put the ID. But the thing is, I like it having next to the ID because it seems cleaner. We can also add another index, which we could put an IDX, a name of a underscore product name, right? And we can just reference this as product underscore name. And the reason why you could have this is because when you query a database, it takes longer to search for something without an index. But I'm going to take this out and I'm going to show you later. I'm going to add this and show you the difference. So if you're going to now create the table, great. What this will do is, if the category with specific ID exists, then you'll be able to insert into this table. If it doesn't go ID, the category, because it doesn't exist in table of categories, you won't be able to insert it. It's a lot more safer. Instead of, you know, randomly by mistake you get another category that you don't actually sell. Also, one thing I forgot to do is, if you already have a table and you're still keeping this command, you could put if not exists, which means it won't throw you an error, but if it already exists, it won't create it. If it doesn't exist, it will create it. Okay, so I thought that'd be quite good. Typically, you will see this on your VS Code when you have a DB SQL. You will see those commands. But now, as we created this, I'm just going to leave this. We're going to go into here. You have categories. Now we need to insert some products, right? So insert into products. We're going to do multiple products values. So we need product name, price, quantity, and a category ID. And I will show you how this gets inserted. Because when you have a e-commerce website, it will already know the category of the ID. It's all programmatically done behind the scenes. But when you structure database, you need to know how this sort of works together. It's good to know how you do it manually, compare how programmatically you would do it. So we have a laptop, we could have put a unique names on them as well, but we could add this later. And category, now we need to put ID. So we have this ID, and laptop is electronic, so it's ID 1. I think I misspelled. No, I haven't misspelled that. I just didn't put comma here. That's the one comma. I forgot what it was called. Right. So we got laptop, product name, price 800, quantity 10 of them in stock, and the category ID is 1. So we have now inserted. But if I change this to like ID 8, which we don't have it here, and want to insert it again, it will throw me an error, cannot add or update a child row. A foreign key constraint fails, so it won't allow me to insert something that the ID doesn't exist in categories table. I think it's a safer mechanism that way. Let's put phone 500, that'll be ID 1. Let's not 11 but 1. Let's put multiple values so it saves us time. Coffee maker. Has this got this description? That'll be home appliance, wouldn't it? Yep. What's this price? 120. Oh no, sorry, that's 60. That'd be too expensive. I wouldn't even pay for that. And that's ID of, is that home appliance? Yeah, 2. The accessories I think is without. Yep, so we will do this separate. Next one is desk chair. That's 120. 25. And the ID for that is 3. And the last one is gaming mouse 40, 30, that's 4, right? Accessories, yeah. So let's execute this. all of them have been inserted. Let's find the products. So we have IDs here. Okay, let me just refresh the table. So over here we have a products, categories, and users. So again, we could use this command of show tables, which shows us all the tables. Okay, now how can we fetch the, let's say, products that only have perhaps the electronics, right, with category of electronics, and how we can join them? So I'm going to show you what I mean. So let's select all from products, and then we have join on categories. So we need a table, so we want to join those two tables. So we got one table that we select, but we want to join another table, and I shouldn't put on here, so remove this categories. This is where we want to join them on IDs. So I got here ID equals to products dot category, let's go ID, and I'll show you what that will look like. That'll be a big table. So over on the left side we have the products, on the right side we got the category. So ID 1 of product, laptop, price 800, quantity 10, category ID is 1, which is electronic for this. For coffee maker, category ID is 2, and the ID of that will be 2 as well. So you can see they match each other. Now if we want to find, for example, where categories dot ID equals to category underscore ID, we could put a prefix for that, which will be products dot, to make it more exclusive. I think product ID where category ID equals to, I think I selected this the wrong way. Yeah, hold on a second. Let me just copy this here and right. Select from all products, join categories on categories ID equals product actually where category I know why. Okay, that should be fine though. Category ID, which is this, matches to categories. But if we put, I don't know, 1, so we get this as a category ID, but what I want to do is select where category ID equals to categories dot ID. Yeah, so I think I made a little bubble, and that's absolutely fine because I want you to see this, because these things can happen. And then, you know, what do you do where obviously you need to select something else, right? So let's have a look. Let's select by ID because the clause is there. No, that's not correct. where, yeah, it should be, because we're doing my categories dot id equals to product. Yeah, it should be fine. I'm not too sure why it's throwing me an error. I know I made a mistake somewhere, and it's absolutely fine, because without that you cannot debug it. So let's find this, where this is. It's not here. It should be working. I know I made a mistake somewhere. Select all from products and join the categories on categories ID equals to products category ID, where categories ID, it doesn't matter which way I put this, products dot category ID equals to I think because we selected, yeah, I know why. Okay, I made a mistake, because the problem is because I was thinking of program, and then actually change my mind of on using this interface. This is where we manually need to select an ID, so like 2, right? So this is the mistake I made. It's just because I'm used to with programming, and I would select the category. You already have that category saved in a variable, so that's what I was thinking of. So everything works fine, you know, it's just a mistake that I made myself. Anyway, so if you ever come across like that, it's because you just need to change your shift of thinking. Okay, so we could select product name, category name, and price quantity as well, right? And we get this. So if we go to number 1, maybe we could have a here categories.id and products.id. I just want to show you the difference here. So obviously we got different IDs for the products, we got different ID for the categories from categories, but also if we have next to, just before this, could have a category underscore ID. So we have our product ID and then product name and the ID that is assigned to, and we got category name, price, the quantity which is in our products, and the ID of that category. I just wanted to separate this. Maybe if I put this next to category name, make more clear. So ID of the product that was inserted in the products table is 1 and 3, which is laptop and phone, and the category that they will be assigned to is ID of 1. The category of ID 1 is electronics, and it shows you that this is the ID which matches that, and obviously this is from the table products. I just wanted to separate to show you the separation, otherwise could have got confused, but everything works fine. It's just my mistake that I made based on programming thinking. Now what we could also do, if we go to select all from products, is we could basically order this by quantity or price or date and time. So let's have a look how we could order this by. The other way, the clause that is, it's called order by, and that way we could order something with ascending or descending way. Okay, so let's do this. Products order by let's say maybe price. By default is ascending, which is from the lowest to highest, which is ASC, right? And you will see. But we could do it from highest to lowest, which is DESC, descending. This is the most expensive item. This is the most cheapest one. And we could also put a comma and put by quantity as well. Or we could put DSC as well on quantity. Well, sorry, we can't actually put it because that is not how it's done. So the descending or ascending always go last. So it looks by the quantity, then obviously the price. So the highest quantity we have is 30, and that's why the price, it's not the highest as a sort of the most expensive, right? Because it looks first as a quantity and then orders them by quantity, then the price itself. So just I would say you could keep it to 1 because probably is the best. It's kind of a bit pointless to do both in setting. I know there's a way to do multiple orders by where you could, let me just have a look. We could order by the first name and the last name of a user as well. But again, I think when you look at the products, the price would be looking at which is the highest price and which has the most quantity, right? You could use it by IDs way, or the users. If you look, select all from users, we could, for example, look at a order by date. So order by created at descending if you want to, and Charlie Brown becomes as a first user, right? But the next thing I want to do is show you how the foreign key constraint can come into a place when you have orders. Okay, so we need to create a table. Let me just give my data, and then you have orders. So we got ID, int, primary key, auto increment. You should be used to this by now. User ID should be an int, not no. Then we have a product ID, int, not no. Order date, so this will be timestamp, and then not no, so default would be current timestamp. Quantity, quantity will be int, not no, and the total price. Well, I'm going to leave the total price for now because it becomes a little bit more advanced on calculation and functions to use. So at the moment I want to leave this, and we don't have a well, we do have a price, but you know what, let's put a price. Okay, so what we need to do is create a foreign key constraint. Okay, to do this, what we need to do is basically very simply says foreign. I don't know if I spelled this correctly. Maybe no. For foreign key. So the first foreign key is going to be user ID. References users table ID. The second foreign key is going to be products ID. I think there's an S missing, it's from me in an error. So, damn it. References products ID. So how do you create a condition where you could delete the products based on the user? On delete cascade. So this condition will delete the data that is inserted into orders once the user closes the account. However, you might want to keep this, but I just want to show you how this works. Insert, we don't need this. Okay, I made a mistake somewhere. Current products D doesn't exist in the table. Product. I don't know why I put S. What now? Product ID doesn't exist in the table. Well, it does exist in this table. Where is this error from? Int, not now. I misspelled that. Product. That's why. There you go. See, you have to be careful how you spell stuff. So, let's insert data. Insert into orders. So we need a order ID. We don't need order ID because that's auto increments. We need user ID. We need product ID. We don't need order date. We need quantity and a total price. Not select. Why is select coming up? So values. So user ID would be 1, product ID would be 2, quantity would be 2. What is the product? Let's select. So we don't have an ID 2. Did I delete? 1, 2. Okay, well, we don't have a 2, so we're going to change it to 1. That's a bit strange. Hold on. User ID, product ID, quantity 1. Let's do 800. Let's insert this first. Okay, and now column total price. Did I not put total price? Oh, I put price. Okay. What? Cannot update or child row for frequency fails. Well, we have a user ID. I know why, because the user doesn't exist with ID 1. See, this is what it means. So let's select users. You need to be careful with this, yeah. So let's use user 2, product 1, quantity 1. See, this is why foreign key constraints gives you a condition there, right? There you go. It's inserted. Let me just use another query tab. Select all from orders. Right, we got over here. That works. Now the next one, order ID we don't need. User ID we're gonna have 3. Product ID oh buddy, come on. Products, let's say coffee maker 4. Quantity 1. And what price is this? 60. And let's insert one more. User ID of 6. Right. Say 6, product 5. What's the price for that? 120. 120. Well, 240. Let's do it because it's 2. So we got these 2, right? Now we could have a look at this where select all from orders, join users on users.id equals to orders dot, and we got this nicely, where user.id equals to 6. And I again messed it up somewhere, where users s. There you go. So the ID of order of this would be 4. Where is the orders? Is it orders? Did I do this? 5 ID order 4. I know why it didn't generate 1, because of the error that was thrown in. So technically it assigns a ID to it once it's created, but when it throws you an error, it doesn't insert stuff. So that's why, just in case you wonder why it's not 1 but it's 2. So that's for ID, which matches. User ID is 6, and the product ID is 5, which is fine. And the order, date, quantity, and the price. We could have put product name as well, insert this, but then what's the point when we could fetch the product name by the ID, right? So price, ID, or ID of the user, first name, last name, email, created at. So what we could do is, let's say, use from orders, and also we could put join products. I think I need to put a comma here. Join, you know what, it's on here. So let me just drop this down, be easier to write. You could do multiple joins. Join products on products .id equals to orders product ID, where users dot ID equals to, what was it, 6, and we have this long query, right, which we could put, let's say, product underscore name, price, or maybe let's put first name, last name, product name, price, before price maybe put quantity and price. And I made the mistake again. I misspelled quantity, did I? Quantity. I didn't. So orders. I need to now orders. Do I need to name them now like this? Yeah, there you go. For some reason it was causing an issue because of the way it's selected. So we got the first name, Charlie Brown, the product they selected, the quantity, and the total price. So these are the conditions you can do. There's a little bit more advanced where you could put like if else statement, you know, if else. So you could do this with case, where, and else. But we don't have enough data to do this, so that's probably we'll have to go for more advanced. But hopefully this basic helps you understand how to do SQL queries, how to create database, tables, how to insert data, and so on. The last thing I need to show you is when the user gets deleted, right? So we have the products, and we're going to delete user with number 6 ID. So delete from users where ID equals 6. We have deleted the user with ID 6, and I want you to pay attention to this because this is going to be gone. So we don't have that. Now we want to select all from orders, and we don't have that product with the user of ID 6 because they're deleted. This is why having certain clauses might be good or bad. It depends what you're doing there, but hopefully that shows you. And again, hopefully you learned something here. It will be useful. You could practice, you could rewatch it, but this is the basics. I will cover a little bit more advanced stuff later. There's a lot more clauses that you could use as well, but I don't want to cover this in one video because it's already been an hour of this. So I will probably do another one and break it to the second part of this. This is part 1, and we'll do part 2 soon. So I will see you on the next one.